Hi there, welcome to Nauctis on YouTube.
The Space Shuttle plays a crucial role in transporting astronauts for missions and space exploration. One vital component for launching the Space Shuttle is the Solid Rocket Boosters, or SRB. The SRBs are the first solid-fuel rockets used as the primary propulsion system for spaceflight vehicles. Each of these rockets measures 45.6 meters in length, 3.71 meters in diameter, and weighs 590 tons. Their primary propellant is ammonium perchlorate as the oxidizer, atomized aluminum powder, iron oxide as catalyst, PBAN as a binder, and epoxy curing agent. This propellant is commonly called composite ammonium perchlorate propellant. Each solid rocket motor contains 500 tons of propellant. There are several main elements in these boosters, such as the motor, structure, operational flight instrumentation separation systems, recovery avionics, pyrotechnics, deceleration systems, thrust vector control systems, and range safety destruct systems. Each booster is attached to the external tank of the aft frame of the SRB with two lateral sway braces and diagonal struts. The forward end of each SRB is also attached to the mobile launcher platform aft with 4 hold-down posts with fragile nuts that fracture at liftoff. The boosters consist of 7 individually manufactured steel segments assembled by the manufacturer, then shipped to the Kennedy Space Center by rail for final assembly. Each solid rocket booster has 4 corresponding hold-down posts on the mobile launcher platform. To mate the SRB positions with the launcher platform, hold-down bolts are required for its upper part. The upper bolts contain 2 explosive charges initiated by NASA standard detonators, which can be fired upon solid rocket motor ignition command. When both standard detonators are fired, the bolts will break, releasing the hold-down posts. The studs move downward due to the release of tension on the stud, the gas pressure of the standard detonator, and gravity. The posts are stopped by the deceleration posts containing sand. The hold-down posts are 710 millimeters long and 89 millimeters in diameter. This launch process is monitored through the mobile launcher platform to detect low voltage during the final 16 seconds before launch. After launch, the Space Shuttle's main engines will automatically ignite and begin thrusting. When lifting off with the Space Shuttle into space, a pair of SRBs automatically provides 85% of the thrust when the Space Shuttle, especially during its first 2 minutes of launch. Once the SRBs have expended their energy, typically reaching an altitude of 45 kilometers above the Earth, they are jettisoned from the Space Shuttle and parachuted into the Atlantic Ocean. The separation begins when 3 solid rocket motor pressure transducers process in redundancy management, selecting the midpoint pressure value and the head end chamber pressure of both SRBs in less than or equal to 340 kilopascals. The SRBs will also separate from the external tank within 30 milliseconds after the ordnance firing command. After the SRBs are jettisoned, the range safety system provides for the destruction of the rocket or its components with explosive material inside. To detonate, a remote command is sufficient to limit hazards on the ground due to falling debris, explosions, fire, toxic substances, etc. This system is only activated once. The range safety system consists of 2 antenna couplers, a command decoder, a dual distributor, a safe arm device with 2 NASA standard detonators, 2 limited explosion fuse manifolds, 7 CDF assemblies, and 1 linear charge payload. It should be noted that when these SRBs have been dropped and re-enter the denser atmosphere, they are slowed down by the parachute system to prevent damage from impact with the sea. The first command is sent from orbit to the SRBs just before separation to apply battery power to the recovery logic network. Meanwhile, the simultaneous second command arms 3 nose cap thrusters, a frustrum ring detonator to deploy the main parachutes, and the main parachute arming devices. In fact, these SRBs are not simply discarded into the ocean. Instead, they are retrieved, examined, refurbished, and reused. To recover these SRBs, NASA deploys 2 recovery ships, namely MV Liberty Star and MV Freedom Star. Both ships are operated to retrieve the spent SRBs dropped into the ocean after space shuttle missions. Although owned by NASA, the United Space Alliance, a spaceflight operations contractor, operates both ships. As information, NASA's SRB recovery vessel MV Liberty Star was built at the Atlantic Marine Shipyard, located on Fort George Island, Florida. Upon completion, Liberty Star was delivered to its original owner, the United Technologies Corporation, in January 1981. The vessel measures 53.6 meters in length, 11.3 meters in width, and 21.9 meters in height. Liberty Star is powered by General Motors EMD 12645E6A diesel engines and Detroit diesel 8V71 engines. With this, the vessel is capable of reaching speeds of 15 knots or approximately 28 kilometers per hour. The vessel, capable of accommodating up to 20 crew members, also has a towing capacity of 27,200 kilograms. Not only tasked with recovering Space Shuttle SRBs, Liberty Star has also been used to tow the external fuel tanks of space shuttles from their assembly plant at the Michoud Assembly Facility, New Orleans, Louisiana, to the Vehicle Assembly Building at Kennedy Space Center, Florida. Meanwhile, MV Freedom Star is another vessel owned by NASA and operated by the United Space Alliance to recover SRBs after space shuttle missions. Similar to its counterpart Liberty Star, Freedom Star was also built at the Atlantic Marine Shipyard and has been used as a tow vessel for the external fuel tanks of space shuttles. Its size and speed are identical to Liberty Star. After the retirement of the Space Shuttle in July 2011, these recovery vessels were reassigned as training ships in different locations. MV Liberty Star was transferred to the United States Department of Transportation for use as a training ship at the United States Merchant Marine Academy. After being delivered on September 13, 2012, the vessel was refurbished and renamed 𝗤𝘂𝗃𝗀𝗁𝗀. As for Freedom Star, it was transferred to the United States Department of Transportation's James River Reserve Fleet on September 28, 2012 for training ship purposes. However, before being transferred in April 2012, NASA operated MV Freedom Star to track commercial orbital space flights with SpaceX's Falcon 9 launch vehicle to the International Space Station. When operating as SRB recovery vessels, both ships are deployed to the splashdown area to locate and secure the boosters. Liberty Star and Freedom Star are equipped with sophisticated navigation and tracking systems that help them locate SRBs as quickly as possible. After successfully locating the boosters, dive teams are deployed from the ships to rig the boosters for recovery. This task requires precision and skill to ensure safe and secure rigging in various sea conditions. Once rigged, the boosters are towed back by these vessels and delivered to shore. Upon arrival at the shore, the boosters are immediately taken for refurbishment and repair at specialized facilities within the Kennedy Space Center. The inspection and repair process is thorough, involving dismantling the boosters from the outer casing to the smallest internal components. If damaged or worn parts are found beyond specified limits, they are either repaired or replaced. Propellant sections, parachutes, and booster casings are also replaced with new ones. Upon completion of repairs, the boosters undergo rigorous testing to ensure they are still fit for use and meet safety and performance standards before being used for the next mission. There are several challenges in the booster recovery process, from unpredictable ocean conditions to technical difficulties in refurbishing SRB components. Therefore, NASA is always actively creating sustainable innovations in materials, technology, and other procedures to overcome these challenges.